Good day. In this video, we're going to look at the circle geometry question. I'm going to show you a way of answering it. Always take special note of the instructions they give you at your sketch. Here they said, refer to this figure over here. They said AB and AC are tangents. These two lines are tangents. And they said that BDE and FDC are straight lines, the two lines I drew in there. The first question asks, prove that AB is parallel to EC, those two dotted lines I put there. Prove that they are parallel. I started in circle FBDA. I started on that circle. First we can write angle A2 is equal to angle B4. The reason is tan chord theorem. There's the tangent, there's the chord, and there's the angle opposite, so those two angles are equal. Then you can say angle A2 is equal to angle E12, angles in the same segment, those two angles. Then we write angle B4 is equal to angle E12 because they're both equal to angle A2. This reason you don't have to write. Then we write AB is therefore parallel to EC. Why? Because the alternate angles are equal. So these two lines are parallel because the alternate angles there are equal. And remember, when you work out something in geometry, you put it in on the sketch. Please stop the video and get your brain around this. The second thing they ask is, why is AC parallel to FB, the two other dotted lines now? I wrote here, it's very much like the above one. We write A1 is equal to C9, the two blue ones. Again, the tan chord theorem. There's the tangent, there's the chord, and there's the angle. Then we can write A1 is equal to F, also angles in the same segment. You can see those two angles there are in the same segment in the small circle. So angle C9 is equal to angle F, because they're both equal to angle A1. You don't have to write this reason. Then we can say AC is parallel to FB, because the alternate angles are equal, and we add it in on the sketch. Please stop the video and get your brain around this one. Next, they ask us to prove that angle D6 is equal to angle A1 plus A2. Let's look at one of the ways we could do it. First we wrote angle D6 is equal to angle E11 plus E12, exterior angle of a cyclic quad. Then we can write angle A1 plus A2 is equal to angle E11 plus E12, tan chord theorem. There's the tangent, there's the chord, and that angle is equal to the angle opposite that chord. So now we know that D6 is equal to A1 plus A2. This you don't have to write, but they're both equal to E11 plus E12. Please stop the video and get your brain around this one. Please stop the video to get your brain around the last one. It says here, prove that AD bisects FDE. It means this line cuts that brown angle in half, but that's too complicated for our brains. So bisect means that D6 must be equal to D7, so those two angles must be equal. We don't have to worry about bisect, as long as we understand it means two equal angles. So we wrote angle D7 is equal to angle C10, angles in the same segment. So that angle is equal to that angle. Some people call it angle on the same chord. Then you can write angle C10 is equal to A1 plus A2 because of the alternate angles, and those two lines are parallel. Then we can write angle A1 plus A2 is equal to D6. We proved it in the previous part of the sum. So D6 is equal to D7. Let me just write AD bisects angle FDE. Please stop the video and get your brain around this. If you didn't totally grasp what happened here, please type in on YouTube geometry, logic, mathdou, and then you'll get a feeling on what we did over here. Please indicate whether you liked or disliked the video and subscribe to the channel. Enjoy the geometry.